Hello and welcome back. We are already on the very last day of the Handmade Network Wheel Reinvention Jam. I didn't have much time to work on the project today, so I focused on adding some helpers for the DSP. So here in my API.h file, I added some functions for making some basic oscillators, so that you can easily add some sine waves or triangle waves or sawtooth or rectangle oscillators into your DSP procedure. I also added a small helper to ramp between a starting value and a target value. I also added a curve reader, which is useful to make envelopes. So you give it a curve and a length, and you can trigger it and it will read the curve, and you can read the current value of the curve. And last, I added a B-quad filter, which is a useful building block for making all sorts of filters. And I added some helper here to set the coefficient to a simple first order low pass filter. And then you can give the filter an input and read the output of the filter. Each of these functions have two variants. So here I can read just one sample of my oscillator, or I can pass it buffer and request that my oscillator renders into that output buffer. Same thing for the envelope reader. Here we can render a portion of the envelope into an output buffer. And here for the filter, I can pass it an input buffer and it will write the filtered signal into the output buffer. So I added DSP helper.c file, and here is the implementation of these DSP helpers. So we have functions that compute a sample for different kind of waveforms, and OSC sample is just switching on the shape and setting some function pointer to the correct shape function, and then we are just computing a sample and advancing the phase of the oscillator, and we are wrapping the phase around 2 pi. The ramp helper takes the value we want to ramp. It takes pointer, so it will modify the value. It takes a ramp time that will be also modified, target value, and the interval during which we want to apply the ramp. And so we are just doing a linear ramp towards the target, and we also decrease the ramp time by the interval value. So it allows us to smooth values, for example, that would be changed by a slider, and we don't want to change them too abruptly, so we can smooth them. Here we have the envelope reader. We can trigger the envelope or set its length. If we are triggered, we set running to true, we reset the time to 0, and we set trigger to false. And then if we are running and we have some length, We sample the curve, dividing the envelope time by the envelope length, and we advance the time. If the time is more than the length, we can stop the reading of the curve. And finally, here I have my biquad filter, and here my helper to set the coefficients of the biquad filter to some first order low pass filter. And here I just apply the biquad filter equation to get some output sample, and I update my biquad registers here. So those are simple helpers to make life easier in the DSP procedure. So let's see how we would use them. So here in my dsp.c file, I have created another kind of synthesizer. It's just edge oscillators that are slightly detuned around a common frequency. I also have a filter and some parameters to control the spread of the amount of detune, if you will, and the slide values that allow the frequency to take some time to ramp to target values. And I have my cutoff frequency of my filter. I also added an on-off button and a volume slider. This function just updates the oscillators, so it computes the frequency of each oscillators according to the central frequency, to the detune parameters, and to the spread parameter. Here in my DSP procedure, I get a persistent memory block for my parameters. I initialize them if it's a new block. If I have changed my cutoff frequency, I recompute the coefficients of the biquad. And here I loop through all samples, and I ramp my center frequency. I update the oscillators. If we are on, I sample each oscillator and I sum them. I filter the output and I multiply by the volume. And then I fill my output buffers with that sample value. And the UI procedure is also quite simple. Here we're just setting some labels to name our new instrument, which is a swarmatron. We have our on-off button here. We have our volume slider, frequency slider, the spread, the slide, and the cutoff. And here I also added dial knobs to control the detuned value of each oscillators. So let's see how it looks and how it sounds. So here we are. I can toggle the on-off button here and add some volume. So I can play with the detune of each oscillator, trying to find that nasty beat here, probably between two oscillators that have a close frequency. And I can play with the spread value I can change the frequency, and you can see that the frequency is controlled by the slide value. So if I have a very small slide, my frequency will reach the target frequency more quickly. And I can also have the cutoff value. And the filter now seems to also have a non-constant gain, so that will be something to fix. So, quite simple device, just to show some oscillators and some filtering. So here we are. It's the end of the HMN Network Wheel Reinvention Jam. So how has it been going and what did we achieve? I now have a very simple audio live coding environment which offers basic features like audio device selection and configuration, seamless DSP code reloading, and a simple UI widgets and layout API. On top of that, I started to add some reusable building blocks such as oscillators, envelopes, and a basic filter. All in all, I would say I managed to get the foundations I wanted working, and I also got to experiment and learn about topics I have less experience with, such as hot code reloading and auto layout. It has been a lot of fun all along, so the experience was very satisfying. I did spend too much time to my taste fiddling with core audio and trying to scavenge useful information from the docs or from sample code, but I think I now have a better understanding of that area, so maybe I could go back later and make a more robust audio layer device someday. I also wish I had more time to spend on DSP specific features. I feel like I barely just scratched the surface here. And I would also have liked to do some more interesting synthesis demos beyond simple ring modulation, but the infrastructure had to be done first. As for the video series, you can tell I'm not really a YouTuber, and it was pretty unusual for me to document my work in this way, and it also took a lot of time putting it together, so that's time I could have spent programming. On the other hand, it provided a motivation for each day, and it forced me to organize and prioritize my work more rigorously. So it also had some upside. Anyway, I hope it's at least of some value to a few people. So I would say it has been an amazing overall experience. I don't know exactly what the project will become now, but I would certainly like to go back to it now and then if I find the time. I think now would be a great time to do more serious synthesis stuff to really see what is needed. But for now, I could see the project going in several directions depending on what we want to do with it. For example, we would need a lot more features to use it as a real live music making software, such as sampling and sequencing capabilities, and perhaps MIDI and OSC communications, and maybe the ability to integrate plugins. We could also provide a large library of very simple reusable DSP blocks and push it towards a prototyping environment for quickly testing out DSP algorithm before making them into plugins, perhaps. Or we could add more full-featured modules with some associated UI and bring the environment closer to a modular synthesizer. So those different sets of features could be added as libraries that a user can choose from and import in their own module, which would allow them to tailor the environment to their needs. This has been an amazing week. Be sure to also check the other Jam projects on the HMN Network website and come discuss with us on the HMN Network Discord. I'll see you there. Bye.